Do, 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 do. Okay. Really quickly, um, so a couple things that I've had to change. Uh, I've decided that basically what I need to do is I just need to take one type of rotation input instead of trying to make all the rotation types synchronize. So I've changed a lot of this, but update rotation, update transform are the same. But what we do have differently is that now we have 3 different types of rotation dirty flags, and this is also why this enumeration with flags is nice, because it lets you add more booleans basically without actually adding more variables. And effectively, we're just adding single bit flips is all we're doing. So basically, if we set the rotation directly, we're going to remove any dirty flag for rotation angles and look at. Look at is a completely different type of rotation, so you can't actually translate it into a normal rotation because it actually rotates the axes as well. So what we actually need to do here is we'll set it like this, and basically we're just going to, anytime we do a look at, we're going to do our dirty flag. It's going to be actually what we'll do is we'll check to see, like, if actually I don't even think we need to check that. We can just say, we can say dirty flag and equals, and we'll remove the rotation flag and the rotation angles flag, and we'll set rotation look at. So we're going to flip these bits, and we're going to flip the rotation look at to true. And the reason why is because look at this rotation matrix is actually it actually rotates the axes as well. And that's what all of this is about, because it basically starts with a single Z axis, then it determines the other axis. That's why when you create your actual transform matrix with this, you have to use the negative I position, and that's actually a problem in our case. Anyway, so let me make sure I change this. So is rotation dirty is basically are any of these rotations dirty? Now this gets a little bit tricky because our transform depends on the rotation being one type or the other. So we kind of have to determine and I'll do dirty flag dot rotation look at. Essentially we want to have this flip, but I'm trying to think. I'm trying to think of our forward vector. Our forward vector will be different. So I almost think that this should only be I wonder if it's just as simple as that the forward vector is flipped. I think it might be. I think it's just that the forward vector is actually flipped, but I don't want to assume that. So let's so we could actually do this. Actually, though, if I look at, is that the same thing? Like, I think that inherently I just did a lot of this wrong, because really we should be aggregating these sort of things, and we're not. We're basically like, look at is basically deciding. Look at is tricky because it creates that translation for the negative I, and it doesn't really help us get. This is wrong too. It's just supposed to be ZX. I'm gonna add this just in case. We're just gonna add a vector3 target. And what we can do is we can do this. What's up, man? So if is dirty look at, then actually what we want to return is position minus target normalize. What's up, guys? How it goes? So I'm back in Rocks object here, because basically what I'm slowly figuring out is that we want to be able to rotate things and objects different ways, and basically I'm not doing it right. So I figured out, number one, why look at Look at is giving me grief, and here's why. Look at is giving me grief because look at creates a rotation matrix that basically transforms the axes as well. So you can't use the position. You have to use the negative position. Or the negative I or whatever. And if you remember, that's why that's what I was getting thrown off about. And it's also why it was flipping my forward vector back and forth, because it actually is flipping everything. And so actually what I've ended up doing is just adding dirty flags for types of rotation and basically making whatever the latest rotation type is set. I'm using that. And but really how it should all work is like anytime you call like a rotate, it should apply a new rotation, or it should basically aggregate. It's getting there. I have kind of one last thing to figure out here is basically our update rotation needs to be pretty much and actually really fast I need to do one more thing. I don't think I'm using my right vector at all, but I should be. If is dirty look at, then we want to return our z and our x, I believe. So for this vector, z is in cross with vector 3 unit y of z. Dude, why do you always want to talk about things that don't have anything to do with the subject matter? I can't program and talk about romance novels. It's just too much. Too much for me. So here's the trick. Essentially, what we want to do is this. We want to set a is the thing is do we not we actually don't want to do this. We don't want to include is rotation dirty. We don't want to. I'm pretty sure we don't want to include. Yeah, you know what? I think that this is actually a bad idea to include the look at with that. And instead, let's use, no, wait. No, I was right. What we're not going to do, hold on. I got to mute this. What we're not going to do is unset this, because unless we're setting a rotation directly, or unless we supply rotation angles, which we can do here, and we'll just do and equals, because I also think that we need to reset the angles if we set rotation directly. So essentially what we need to do here is dirty flag rotation, or dirty flag rotation look at. So anytime we set a new type, we'll clear out the old types. So at this point, this is look at and angles. So look at and rotation angles. Just so it's clear, basically what we're doing is we're keeping these flags for the types of rotation. So if we do a rotation by setting the rotation directly, we flag it. If we set it by angles, we flip the other two. We don't get translation is completely separate. If we do a look at, we need to set the location look at here, and we reset the other two. The only tricky part here is that when is rotation dirty, do we want it to return? I don't think so. Maybe we do. Yeah, this is what we'll do. Our update rotation will basically say if is dirty look at, will always return true for that. What's up, bot? How's it going, man? It's okay. I can't respond to you if you use other languages. So I'll do is look at, and we'll figure out dirty. We'll just do we'll do the is check here. Is dirty look at. Actually, it doesn't matter. We can do this. We don't have to do this before update rotation, because update rotation isn't actually going to update rotation only flips these things. And also it's going to return anyway, so it's not even going to matter. So update rotation is not going to matter here, but this is what does matter. So our translation is going to depend on is dirty look at. And depending on whether or not we have a dirty look at is going to depend on what our position is when we create our transform. So if it's a dirty, we want to use a negative position. And if it's not, we just wanted to use regular position. Like that. Or even more, to make it even simpler, we could just do this. Var position equals is dirty look at, negative position, else position. And then we can just create translation position. Now this isn't great, to be fair. But dirty flag, not rotate, no, translation. I will. And clearly something doesn't work, so I think maybe we're flipping it. Our direction probably needs to be the target minus. Damn it. All right, so I'm not even sure now what's not happening here. So update transform. So let's set like maybe like a breakpoint here. So I just set it here. Let's set it here for the camera. And we can set it, we'll use conditions and we'll do name equals main camera. Close. So this actually should break here. So this is coming from, actually let's move to the next one. So this is being called from transform.get update viewport. Let me make sure this is the right. Oh, this is a different one. Okay, let me make sure. I'm trying to get basically, here we go, from draw. This is what we want. Oh, we have transform get. It's going to call this on the camera. We're going to drill down, and then we're going to step through this. What is, so right here, force is true. Let me take off the auto scene switcher real fast because I think that's going to get in the way. So force is true. Oh, well, that's probably why. Okay, so let's go through a couple more times. Update transform, draw, here we go. So force is false. Translation dirty is true because I guess we've moved. Or not, wait, is that not? Oh yeah, translation dirty is true, is rotation dirty is true. Okay, so let's step over. And let's step into this. Update rotation is going to say, this should be true. Yes, it is. So we're going to return true here. Good. And this should be negative position. And this rotation matrix is what I'm interested in. So let me grab this guy. And let me also grab target. See what target is. 0, 0, 0. Oh, that's interesting because that's where it is. That makes sense. So at this point, our transform, we got to step through one more time, or step over one more time, and then we can get the transform. And I'm going to get this value as well. And hold on 1 second. Let me format this stuff. I'm just copying it onto a different into another page. Okay. So from my understanding here, though, okay, so let me close that, and then let me add this look at check here, and I'm gonna do conditions, and I'm gonna do the same condition, name equals main camera. So basically, we don't want to stop for our cube object look at. We only want to stop for. So our look at, our target here is going to be 0. I'm pretty sure. Yeah, it is. And so rotation at this point, just making sure that this is actually checking out to be what it was before. And I think it is. So 0.89, -4, yep. 194388. Okay. So what is missing here? I can't quite figure out what's missing here because this should be right, and actually we should be looking at that object. This is basically exactly what it used to be. I'm not actually moving. The mouse isn't actually doing anything yet. We're just rotating the Y. I'm so confused. Is it this? I wouldn't think so. Well, this is going to be a complete fail of a day because I can't I can't figure out what I broke. If I just set position here, what happens? Well, that's kind of right. So let me open this other project real fast and let me look at what the matrix 4 stuff was doing again, because I kind of feel like it's doing this. It was doing the same thing. So let me go to matrix 4 and let me look at position minus target. That's what we have. No, we have target minus position minus target is what we want. The hell? The fuck, man? The hell you say to me today? Okay, well that actually I think is what we wanted. I could be wrong. Heyo. Heyo. The only, oh, okay. So that, the stuff that I removed was right, I believe. Hey, whoa. Actually, that is not right. Hold on. Up and down were wrong. Wait, so I have the this is the Z. And I have to have a right vector. I think. Vector 3 X. And I think what I want is vector 3 cross X and Z. Oh man. No, this is OpenGL. I'm just using OpenGL bindings. Yep. And so yeah, I'm writing all the so I'm using a third-party library for like the math functions and stuff. And they look pretty similar to Unity's. Although I'm trying to figure out what the hell is. I actually think that up was okay without anything. Okay, it is. Good. So W and S, right, left. Yeah, there we go. Okay, cool. Okay, that works. Forward vector is the only thing that we have to worry about switching around. Okay, so this is good. Although, here's the problem. This is still a problem. We've split it up so that we can do separate types of rotation and stuff. Listen, I've done it a few times and I still forget every single bit of everything that I try to do. Basically, what we've kind of set ourselves up a little bit, and the look at rotation is really the kicker, because the look at rotation essentially borks the rotation matrix. Like, I am not sure how to get a rotation matrix that you can multiply by the positive I. I don't think that you can. So what ends up happening is that when you create the rotation matrix for a look at, it's a rotation matrix that also transforms the axes, and so that you can't keep it in the same space, the same coordinate space, and so that you have to use the negative I position as the translation to give you a legitimate transform that works. So the problem is, when I'm saying like rotate, when I want to rotate around like the X or Y or Z axis, it's actually becoming a problem, because if I have a look at transform, then I'm not really able to apply it. I suppose that I could merge them all somehow. Like, I could keep separate rotation matrices for all of them. I don't know if that would work. I think it might be. I think it might. So if I have like a local rotation X and Y and Z or whatever, and then I rotate, and then I multiply it by that rotation matrix, the one that flips the axes, I still think that I can use the negative I translation and it'll all look correct. Like, we can do like a little test, like where let me do like a little, I'm just going to create like a, I'm just going to call it rot identity. And we'll just keep we don't actually need it to be like this. We'll just keep private float, and we'll just call it rot 0.0f. And let's just make it, I'll just say if this is gonna be a hack for sure. Just to see if I can get this to work. If this is the main camera, what we'll try to do here is all I want to know is that I can get the look at rotation and I can rotate around and keep the same directions or keep the same location and axis. Basically, smoothly rotate around starting at the look at position. I'll just do rot plus equals 0.001. I don't know if that's enough. But what we'll just do is we'll just say we'll create a rotation around for dot create rotation and we'll create it around vector3.unit y. We'll just rotate around the. So what we want to use is standard coordinate system here, because this is going to flip everything into that space, I'm pretty sure. And so we'll just do rot here. So for every other class here, it's just going to keep it normal. But for our main camera, it's going to rotate us. And let's see how this works. So it does. Okay. So what's up, man? How's it going? So it sounds like really what we want to do is we actually don't want to flip all of these. We want to keep all our rotations separate, is what it sounds like. I'm hanging in there, man. We know our look at is done in one coordinate space. I don't think we don't want our rotation matrix necessarily to end up like that. I wish I could just basically what we're ending up with is this, is that if we rotate, the look at rotation basically takes where you're looking and it uses the axes to create the rotation. And so in order to like flip it back, you have to use the negative I position. So whenever we say look at something, I kind of feel like we're always looking at something. Like I feel like it's fine to always have that flipped axes. However, like I also feel like, how do you get it back to regular coordinate space? Like how do you get a look at matrix back to regular coordinate space? I mean, I just feel like that would solve all our problems, and I can't wrap my mind around why we're not able to do that. or why I don't know how to do that. All right. Here's what I'm going to do. I wrestled with this a lot. I started doing a little bit of work before I started the stream, and then I was like, I need to do this on stream. But it's kind of proven to be a very uneventful day. This really only matters for the camera, since our voxels aren't going to be, at least I don't think our voxels are going to be rotating at all. So it may actually be better to take a step back, not try to implement, you know, every part of a camera that we would absolutely have to use, and just figuring out what we need and then going forward that way, because I'm running out of time right now, and or I've run out of time, and this is just not in a good state. It just never has been in a good state. And so I think I'm going to come back and we're going to focus on how do we approach this in a way that we can move forward with, like being able to move the camera with the mouse. Well, not really, because that's the whole point of all this, is being able to rotate our camera based on the mouse, right? And we had a little bit of that happening, but it was broken severely, actually. And I figured that out this morning when I went to go like make sure that I had everything kind of in its place. Essentially what we're going to want is the look at matrix is really the problem, because the look at matrix creates this state, like everything around it. Like when you do a look at, it's not a normal coordinate space, so you can't do really anything else with it. Like you can just get a new transform after you look at something, but like I know there's a way to do this, but I can't figure out how to get the look at matrix rotation to be normalized with the rest of the rotations. And I think like anyone would say, like, look, well, just set it to the identity, and if you actually look at something, then just multiply it out in your rotation baking, right? So you'd have a rotation for axis angles, and you'd have a rotation angle, or you'd have rotations for actually, you just need two. You just need one a look at and one a normal rotation matrix. It's just stupid. What I ultimately want is to say, okay, here's my rotation matrix, just multiply it by the translation matrix for the position, which is basically what I want is this line, or this create translation times rotation. This is basically what I want. This line right here, and I don't want this. This is stupid. But I don't think that I can, I just don't think that I can manufacture, I don't think I can push the, the rotation matrix back into a normal coordinate space. I don't think that's possible. Maybe it is. I don't know. But I'm gonna read some stuff, try to figure it out how to do it. I know it's possible. I just don't know. I don't know the best way to approach it. But anyway, I'm gonna take off. I'll probably be back a little bit later to do a small session, but that's about it for today. Thanks for hanging out, guys. Talk to you soon.